So why this project? I embarked on this journey to develop a system that makes sure it detects the heart disease early on, and early detection means early intervention. So when uh, when that heart disease is detected earlier on, probably the chances of the person actually increase. So why this project? I embarked on this journey to develop a system that uses machine learning to predict heart diseases early on. Early detection means early intervention, and that can make a significant difference in patient outcomes. Like before, now for those who might not be familiar with machine learning, I'll give you a brief overview of what machine learning is, the types of machine learning, and maybe examples, and how it's going to be significant in my project. So machine learning is a subset of artificial intelligence that focuses on developing algorithms, models that allow computer systems to learn and improve from experience without being explicitly programmed using datasets. As we see here, we're going to have three examples. There are three types of machine learning. There is the type of machine learning where you give data with labels, and then there's unlabeled data, and then there is a type of machine learning whereby it's just decision making, which we'll see here on after. That's supervised learning. Unsupervised learning, where the supervised learning is where it's a machine is given labeled data to learn using data that's already known. Then unsupervised learning is given unlabeled data to just maybe cluster it and learn from that. Then reinforcement learning is where decisions are made according to what the computer thinks is right or not. As I've said before, this is going to be the less commonly used type of machine learning, but we will use reinforcement learning to optimize the system's decision-making process. For example, if the system could learn from feedback from the effectiveness of the diagnostic strategies and continuously improve its performance. Uh, this I'd like to talk about the environment, agent, and the reward system of the heart disease detection project. The environment in this context is going to be the patient information with the various features, the age, the blood pressure, and the ECG results. The state of the environment is represented by the current state of the patient data. The patient data we're talking about is what data is the person having or is having right now. The agent is our machine learning model for heart disease, this particular heart disease prediction model. We particularly have some challenges in implementing the machine learning methods, which have grouped into three: the data quality, computational resources, and interpretable models. One of the issues is going to be inaccurate or incomplete patient data, which affects the model performance. This data is going to be no, is going to need to be updated all the time so as to have a better working model. Another problem is computational resources. Resource-intensive training of models, especially with large data sets. We need to optimize algorithms, use cloud computing for scalability. Then another problem is difficulty interpreting complex models. So we're going to work with models which are easy to work with. Ethical considerations and biases. We're going to have bias in training data. We're going to have security and privacy and model fairness. For example, uh, ensuring data security and preventing unauthorized access is going to be one of the ethical considerations, because if one's data is leaked, some of the medical data is very essential. So one's medical data is very essential to them. So we have to build a very secure system. In conclusion, uh, supervised learning is going to be used to provide accurate heart disease prediction, whereas unsupervised learning is going to provide us with subgroup analysis. While ethical considerations and challenges like data quality and bias mitigation are critical, the successful integration of this machine learning technique holds the potential to enhance early detection and personalized intervention in medical health. This will ultimately contribute to improved patient outcomes. As I said before, early prediction leads to early intervention. Thank you for watching my video. As you can see here, this is an illustration of how significant the machine learning is going to be in my project. Uh, there is collection of the heart disease data set. This already exists and the very many variables. We're going to be collecting the input and the variable output. That's for the labeled data, which will actually be used most in this project, as we will see later on. So my project idea is, as I already introduced before, it's a heart disease detection system. Machine learning will crucially tell us what to just predict and give us output to actually know whether this person is at risk or not. So the significance of machine learning in the project is machine learning techniques enable a system to learn patterns and relationships. This is what I've been repeating over and over again, that we're going to be using the patterns that were there before to predict someone's health status in relation to getting a heart disease. The system can adapt and improve its predictions. This is for the unlabeled data. There is some data we're not going to be giving to it, but it can actually find for us new patterns that us as people wouldn't have seen. Then machine learning algorithms can handle large data sets. As complicated as humans are, there are some data sets or these are some amount of large data we can't handle. So this will also help. I'll briefly take you through supervised learning, but as I said before, supervised learning involves training a model on a labeled data set. There are two types of supervised learning: is classification and regression. We give a machine a labeled data set and we give it the corresponding output. So most of the times we know what's coming in and what's coming out. So an example of classification is most people here have dealt with emails. So emails, for example, some particular emails are not useful to this particular person. That's how spam comes about. Uh, According to the emails you actually open and the keywords, you can actually, the machine gets to know that this is spam or not. Then regression is an example of regression is predicting the price of a house based on features like square footage and number of bedrooms. an illustration is this. We've been given a data set and it's already pre-processed data. We know what we're training it as and what the test set is. Once we give in the input, it's supposed to give us a prediction of the result. Now, application of algorithms in and techniques. What is this? In our project, supervised learning can be applied using historical data sets. We're going to be using it with different techniques in supervised learning, like decision trees, random forest. So a decision tree uh, can be used to identify patterns in patient data that contribute to the likelihood of heart disease. Uh, a decision tree is we have a particular input and we have different decisions we can take onto. Uh, Random forest instead is, I would say, clear, more. Let's turn on this. As for our project, supervised learning can be applied using historical data sets, where each instance is labeled with the presence or absence of heart disease. So we're going to be using different techniques in supervised learning to, in our project. For example, decision trees and random forest. So a decision tree is a, a hierarchical model, a tree-like model, uh, where there are possible consequences to every outcome. So there is a possible chance of something happening after the other. So as you can see here in this image right here, we have the root node and what's going to happen in the decision. If you take a particular decision, what's going to happen as the same this side? What's going to happen to it? What state are you going to be in? And what other decision you can make from there on in? Random forest is an ensemble method. It's, I would say, where there are multiple decision trees that are combined to make predictions, and it's called a majority vote, commonly known as a majority vote, to reduce the number of terminal states and everything. There is nav bias, whereby we're going to use conditional probability to get the outcome. SVM, as mentioned in our project, SVM demonstrated high accuracy in heart disease detection. SVM is a supervised learning algorithm used for classification and regression tasks. The primary problem in the heart disease project is classifying whether a patient is at risk of heart disease or not. These particular algorithms will help us to make a decision on that. Or the label that we've acquired will be used in a way that the patient records we already have is going to be associated with a label indicating the presence or absence of heart disease. Features like age, blood pressure, heartbeat, ECG results, and blood sugar will be used as inputs, and the corresponding label will be the output, according to how much it appears in heart disease people who actually put a particular output. So we move on to unsupervised learning. Unsupervised learning deals with unlabeled data, and we're going to use it majorly in our project for just exploration, whereby in unsupervised learning, you just give the machine, you just input raw data, like here. It has its own algorithm. The algorithm you've built, it processes it and gives the output. It just interprets on its own. It's not going to have a particular output that it's known. There is not training a data set or anything, but it's going to give us an output. Uh, Examples of unsupervised learning, we have Unsupervised learning may be used to identify hidden patterns or clusters within patient data. Because we're going to see the techniques coming here on after. We're going to recognize that there are some, as we get to know the patterns and cluster them to help us in identifying and predicting if someone is at risk of heart disease. So the algorithms or techniques plan, we have clustering and dimensionality reduction. Unsupervised learning, particularly uh, clustering algorithms, can be applied to identify groups or clusters of patients with similar characteristics. These can help in uncovering subpopulations with distinct heart disease risk profiles. As long as you know probably someone is coming from a family tree where there is possibility of heart disease, there's possibility of them getting heart disease. Uh, Dimensionality reduction can be used to reduce the dimensionality of the data set, simplifying the analysis while preserving essential information. Remove out the unwanted data and we leave out what is actually required. If probably I'm using heart detection, I only need to, I'm detecting a uh, heart disease. I only need things like eye, eye issues in the past, probably loss of hair. Those things are not useful as I'm detecting a heart problem. So the types of insights or patterns, we have identification of patient clusters and reduce dimensionality insights. So how we're going to handle unlabeled data? The heart disease detection project may involve using large data sets with variety of patient information. Some of these labels are not going to be useful to us as we are detecting the heart disease status. So unsupervised learning will allow the algorithm to explore the structure of the data and pick out what's suitable for us and what is unsuitable, they will remove it. So we move on to reinforcement learning. This is reinforcement learning involves an agent that learns to make decisions by interacting with an environment. As far as this project, this is going to be the machine learning type which we're going to use the least because we already have the data set and we don't expect as much of the system to make decisions on a particular environment. Examples of reinforcement learning, we have gameplay, the game boards and rules, and player making moves. Then we also have reinforcement learning in robotics, whereby the robot takes actions like moving or grasping objects depending on our decisions after interacting one or more times with the environment. Uh, as I said before, we're going to be using reinforcement learning list, but to some instance, we will use reinforcement learning to optimize the system's decision-making process. For example, the system could learn from feedback about the effectiveness of different diagnostic strategies and